Bismillahirrahmanirrahim. Assalamu alaikum. Lecture number 6, Unit number 2, Matrices and Determinant. In this video lecture, we will discuss the exercise question number 13, exercise 2.1 question number 13. The rest of the questions from question 1 to question 12 are already discussed in the theoretical work that we discussed in the previous video lectures. So from question number 1 to question number 12 is the assignment for you people. You can submit that assignment before or on 18 July 2020. You can submit the assignment through this email, or you can also send the assignment through the WhatsApp on this number. Now, why this question is a little difficult, or why we discuss this question. The rest of the questions are so easy. You can do it by just watching the previous video lectures, but this question is a little difficult. Why it is difficult? If you see to the statement of this question, if A is a square matrix of order 3 by 3, so this is your given. This is your given, and you need to show that A plus A transpose is symmetric, and in part number 2 you need to show that A minus A transpose is skew symmetric. In this case, the matrix is not given. You need to consider a journal matrix of order 3. So that's why the matrix is not given. So that's why this question is a little difficult. So we will consider a journal matrix of order 3, and we will show that A plus A transpose is symmetric, and in part 2 we will show that A minus A transpose is skew symmetric. For A plus A transpose symmetric, we need to show that A plus A transpose whole transpose is equal to A plus A transpose, because you people know that a matrix is said to be symmetric if its transpose is equal to that matrix. So now in this case the matrix is A plus A transpose, so this is said to be symmetric if we take its transpose and we get the same matrix again. So this for showing A plus A transpose is symmetric, we need to show this. And when we are showing A minus A transpose is skew symmetric, so for that we need to show that A minus A transpose whole transpose will be equal to minus times A minus A transpose. So when we are showing that a matrix is skew symmetric, so we show that if that matrix transpose is equal to minus times that matrix, then such matrix is called skew symmetric matrix. So to show A minus A transpose is skew symmetric, we need to show this. But the question is a little tricky and difficult because the matrix A is not given. So you need to consider the given matrix must be a square matrix and the order must be 3, mean square matrix. So that's why we can say that order is 3. We are not saying the order is 3 by 3. It is obvious. So I am considering a journal matrix solution for question number 13. Consider a journal matrix of order 3 by 3. So A11, A12, A13, A21, A22, A23, 31, A32 and A33. This is a journal matrix of order 3. You see that there are 3 rows and 3 columns, and this is a square matrix because the number of rows and the number of columns are equal. So this is your journal matrix of order 3 by 3. The order of this matrix is 3 by 3, a square matrix of order 3. Okay, to show A plus A transpose is symmetric, we need to show that A plus A transpose whole transpose is equal to A plus A transpose. So for that, first of all, we will find out the transpose of this matrix. So taking transpose, we get, what is the definition of a transpose of a matrix? Transpose of a matrix means you need to convert the rows into columns or columns into rows. So the matrix will be said the transpose of the given matrix. So I am converting rows into columns. So the first row will be converted into first column. The second row will be converted into second column, and the third row is converted into third column. So this is also 3 by 3 matrix. Okay, now you see that this is the transpose. So part number 1, we need to show that A plus A transpose is symmetric. That is, we need to show that A plus A transpose whole transpose will be equal to A plus A transpose. So I am considering the left hand side of the above equation. The left hand side is A plus A transpose whole transpose. So you know that this is matrix A and this is matrix A transpose. So this can be written as matrix A, which is A11, A12, A13, A21, A22, A23, A31, A32, A33. This is matrix A plus. Here we will write out A transpose matrix, which is A transpose. A11, A12, A13, A21. Remember that that the transpose is actually an operator. If a transpose is applied on a matrix, so it gives another matrix. So you see that this is the transpose, this is A and this is A transpose whole transpose. So first we will add this and then we will take the transpose. So I am adding. So you see that per addition, two matrices are said to be compatible per addition if their order is equal. So this matrix is also 3 by 3 and this is also 3 by 3. So the order is same, so they are compatible per addition. So corresponding elements will be added with the corresponding. So A11 will be added with A11, A12 will be added with A21, because this is the element which lies in the first row and second column, and this is the element which lies in the first row and second column. So that's how they are corresponding. A13 will be added with A31, because this lies in the first row and third column, this lies in the first row and third column, so they are corresponding. And when we are adding two matrices, we add the corresponding elements. Similarly, A21 will be added with A12, A22 will be added with A22, A23 will be added with A32, A31 will be added with A13, A32 will be added with A23, and A33 will be added with A33. So you see that from this and the transpose, you see this is a transpose, the whole transpose. So add this is 2A1 1, this is A12 plus A21, A13 and A31, A21 plus A12, A22 plus A22. So this is equal to 2 times A22, and this will be A23 plus A32, A31 plus A13, A32 plus A23, and this is 2 times A33, and its transpose. So the left hand side, which is actually A plus A transpose whole transpose, so that will be equal to taking the transpose of this. So the rows must be converted into column, or you may also convert the columns into rows. So I am converting rows into columns. So this first row is converted into first column. You see that. The second row is converted into second column, and the third row is converted into third column. So this is the transpose of that matrix. If you see to this is actually your left hand side. If you see to this matrix, this is actually equal to A plus A transpose. When you find A plus A transpose, so this is exactly equal to A plus A transpose. So in place of this matrix, I can write A plus A transpose. So you see that this is actually your right hand side. So this implies that left hand side is equal to right hand side, that is A plus A transpose is equal to A plus A transpose. So what does it mean? It means that if this is your matrix, so its transpose is equal to itself. So when a transpose of a matrix is equal to itself, so that matrix is called symmetric matrix. So therefore we can write, therefore A plus A transpose is a symmetric matrix. So this is the required proof for part number 1. Now part number 2, we need to show that A minus A transpose is a skew symmetric matrix. So for that I also consider a journal matrix of order 3 by 3. So this is your journal matrix of order 3 by 3, same as we consider for the part number 1. A11, A12, A13, A21, A22, A23, A31, A32, A33 of order 3, a square matrix of order 3. Now if we take the transpose of this, so its transpose will be A11, A12, A13. I am converting the rows into columns. You may also convert the columns into rows, the choice is yours, but I am converting rows into columns. You see that the first row is written in the first column, the second row written in the second column, and now I am writing the third row in the third column. So this is the A transpose of the given matrix. Now find A minus A transpose, because this involves A minus A transpose. We need to show this, because if this equation is satisfied, then we can say that A minus A transpose is skew symmetric. So first of all we will find A minus A transpose. So the subtraction of two matrices are done when their orders are same. So you see that the order of A and the order of A transpose are equal, so that's why you can do the subtraction. So the subtraction will be corresponding element will be subtracted from each other. So you see that A11 will be subtracted, this A11 will be subtracted from this A11, because this is the first element, this is the element which lies in first row and first column, and this is the element which lies in first row and first column. So that's why they are corresponding. So from here you will get 0, here you will get A21 minus A12 minus A21, here A13 minus A31, Here you will get A21 minus A12. Here when you subtract A22 from A22 you will get 0. Now I'm subtracting this element from this because they are corresponding. So A23 minus A32. Here I'm subtracting this one from this element. So A31 minus A13. Subtracting this element from this because they are corresponding. So A32 minus A23, and when you subtract this element from this, both are the same, so they will give us 0. So this is A minus A transpose. This is A minus A transpose. Now if we need to show that A minus A transpose is skew symmetric matrix, for that we need to show that A minus A transpose whole transpose is equal to minus times A minus A transpose. So I am considering the left hand side A minus A transpose whole transpose. So A minus A transpose is this matrix, you see that. So taking the transpose of that matrix, so when I take the transpose of this matrix, so the rows will be converted into columns, and you can also convert columns into rows, but I am converting rows into columns. So the first row is converted into first column, you see it, A31. The second row is converted into second column, and the third row of this matrix is converted into third column. So this is your left hand side of this equation. Take minus common from this. So when you take minus common from this, I am taking minus common from this equation. So the minus common will be taken from each element of this matrix. So when minus common from 0, so that will become minus 0. Minus 0 means 0. I am writing minus that here, minus 1. So when I take minus common from here, so that will become A12 minus A21. When I take a minus common from here, so that will become A13 minus A31. When I take minus common from here, so that will become A21 minus A12. This will be 0. This will be is A23 minus A32. When I take common minus from here, so that will be converted into this. It will be written as like this, and this is 0. So if you, this is your required, this is left hand side. So left hand side is actually this. So A minus A transpose whole transpose, this is minus, and if you see to this matrix is exactly the same as this matrix. You see this matrix is exactly same as this matrix. You see, you can compare both are same. So instead of this matrix I can write A minus A transpose. So you see that this is satisfied. So whenever a matrix is equal to a matrix transpose is equal to minus times that matrix, so such matrix is called skew symmetric matrix. So we can say that this implies that A minus A transpose is a skew symmetric matrix. If someone doesn't know still the definition of symmetric and skew symmetric, so I am revising that definition here. If A is a matrix, so its transpose is denoted by this. This is the transpose of matrix A. And how you can take the transpose, convert rows into columns or columns into rows. Now if A transpose is equal to A mean when you take the transpose of a matrix and you get again that matrix. So such matrix is called symmetric matrix. And when you take the transpose of a given matrix and you get minus times that original matrix, so then that matrix is called skew symmetric matrix. So we use these two definitions to solve this question number 13. Thank you.